Hey, how's it going? Before we jump into the content, I just want to take a minute to thank you for stopping by the channel and checking out the content. If you like this content and you want to support more content like it, then make sure to subscribe to the channel and like this video. You can also check out the YouTube membership program and cybertrainingpro.com, where I put practice exams and other things that I couldn't put on YouTube. Again, regardless of how you support the channel and my content, I couldn't be more appreciative. Thank you so much, and let's get into the content. Several years ago, if you needed to run some type of service, you would go buy a physical server, install what you needed on that server, and let it run. You might end up with all these different servers with only a few services running on each of them. One of the problems that we've had with servers and systems is that we frequently underutilize the hardware by not taking advantage of all the available resources. You might be sitting there asking, well, what about overutilization? And there is a potential for that, especially if the system receives a lot of traffic, but it's usually not the case. Luckily, virtualization has helped us get to a more efficient point to resolve this underutilization problem. The term virtualization is typically associated with running virtual machines or VMs, which imitate a physical system. For example, you might have a VM, also called a guest system, running the Microsoft operating system, but your host system is a MacBook Pro. A single system can run several virtual machines depending on how much resources it has. We call this type hardware virtualization because we are virtually hosting the system. Each VM has a certain amount of RAM, CPU power, hard drive space, and so on, and the virtual machines themselves are ran and maintained by a piece of software that we call a hypervisor. When you look at a virtual machine, it's stored as a bunch of files that you can move around to other systems if you needed to run the VM on another system. A few common hypervisors include VMware's ESXi, VMware's Workstation Player, and Oracle's VirtualBox. When it comes to hypervisors, there's two types that you need to know about. Type 1 hypervisors are installed on the system instead of an operating system. These are very common in data centers and enterprise environments. Type 2 hypervisors are installed on top of the operating system like a piece of software. These are more common in labs or on personal computers. A key concept when it comes to virtualization and how technologies are implemented today is called abstraction. This is the idea that we can separate pieces of the OSI technology stack so that they can perform their function on their own. Specifically with virtualization, we're taking a physical device and we're turning it into a virtual, logical, or basically software. They all mean the same for this discussion. By doing this abstraction, you can easily change or move pieces of the topology or network without impacting the others. Containerization is a topic that I want to make you aware of. It's a form of virtualization, but instead of traditional virtualization, it relies on the operating system of the host system, but it takes up far fewer resources than a virtual machine. This is a more complex concept than you'll see on the Network Plus, so don't worry too much about it right now. Virtualization has several benefits related to flexibility, so let's go ahead and cover those right now. With virtual machines, you can easily reroute inputs or outputs. Unlike a normal computer, where we have to plug these devices in physically, you simply have to just go to the settings and set it up. This allows you to access or share data and features like printing between virtual machine and host systems. VMs also allow you to relocate components easily. For example, you can add hard drive space, map new drives, or change the location of components. Normal systems would require you to use a lot of effort to do this. With virtualization, you can also easily reduce or combine resources like RAM, CPU, and others. For example, instead of trying to buy a 20 terabyte drive, which doesn't exist, you can group storage drives together. You can also easily scale your system's resources. It's true that a single system can host a lot of virtual machines, but it's as easy as clicking a button to increase the power up or down as you need it. Virtualization was one of the first major steps in advancing how we use technology efficiently and avoid some of the issues that exist by continuously implementing physical hardware. Implementing virtualization at the basic level still means that we're hosting the systems and services on premise, which means on our work site and in our data centers. Cloud computing takes things even further and moves to specialized machines and hosts them out there somewhere using the internet to connect the systems together. At a high level, some items that you need to consider when adopting the cloud include using the cloud is easily scalable, meaning that you can scale up by adding resources like RAM or CPU power, or you can scale out, meaning that you can actually add new virtual machine instances, which is also called elasticity. Just like any system in the cloud, you'll have a root account that controls all your infrastructure. Never allow normal users to use this account and keep least privilege in mind. Privacy can be a concern, but luckily cloud providers usually have some kind of encryption solution for your data. Multi-tenancy allows more than one customer to be hosted on a server, which can drastically reduce your costs, but it also might be a security concern. Intrusions can happen just like with on-premise solutions, so make sure that you use services like intrusion detection systems. All of these systems generate logs, so make sure that you're monitoring systems and activity. When it comes to the cloud, there's service model deployments that you absolutely have to know and that we're going to discuss in the next few slides. The service models are infrastructure as a service, platform as a service, and software as a service. And as we go through these different models, pay attention to the user responsibility and the provider responsibility because it does vary based on the model. I want you to think about infrastructure as a service, or IaaS, as literally taking a full server, operating system, and all of that and putting it into the cloud. One of the benefits of this model is quick provisioning because you can set it up and tear down the infrastructure on demand, which means whenever you want. It's also scalable because you can add resources as you need them. And last, it's economical because you only pay for what you need or use. As far as the cons, there's a few really important ones that you need to focus on. For one, you're responsible for the entire operating system of the server, which means patching and administration. You might also need to bring licensing with you for specific software. Some of the common providers include Amazon Web Services, or AWS, and Microsoft Azure. Platform as a service provides you with the infrastructure in place and you build a platform on top of that. For example, if you want to install and run a web application. Now, some of the pros include that there's no need to worry about the underlying infrastructure as it's all handled by the provider. You don't need to patch the operating system. As a matter of fact, you won't have control or access to the underlying system. It's also simpler deployment than IaaS, and you need less technical knowledge in order to manage it. So what about the cons? Well, you're going to have less control to the system in order to customize things. You also are going to rely on the provider to maintain the system and the patching, which could be nice, but it also could be a problem if they either don't patch frequently enough or they roll out patches too quick and they break things. A couple common providers include GoDaddy and Amazon Web Services, or AWS. Software as a service gives you access to a web-based application and is usually subscription-based. A common example is an application like Salesforce that's used for managing customers. Some of the pros include that your responsibility is the settings within the application itself. You don't have to worry about the server or even the platform version. The provider is going to handle all that. SaaS is also the simplest service model with the least technical knowledge required to maintain it. So what are the cons? Well, it's the most limited service model as far as what you can do. You get zero access to anything outside of the application menus and settings. And of course, it's subscription-based pricing, so you're going to be locked into certain options. When we talk about cloud, we're typically talking about the infrastructure side of things. Believe it or not, though, there's this move to get everything as a service, and many cloud service providers are offering the ability to host desktop systems in the cloud. If you've ever heard of virtual desktop infrastructure, or VDI, it's kind of the same idea to host client systems on a server, but it's in the cloud, unlike VDI, which is actually on-premise. There are definitely benefits to centrally managing desktops like this, but it depends on your business objectives and strategy when it comes to technology. In addition to the cloud service models, you also have to consider the deployment model that fits your business needs. The types of cloud deployment models fall into one of the following four categories. Public cloud, which is the most commonly associated model, and it's what the general public can sign up for and use for their cloud needs. For example, AWS, Google, and Microsoft are all public cloud providers. Private cloud is useful when a company needs the flexibility of the cloud, but they want to maintain ownership of their data. That means that a company builds out their own internal cloud that meets their specific needs and hosts it in their data center. Community cloud is like a private cloud, but it's used by more than one organization that has similar goals or needs. For example, if you had several healthcare companies who had the same privacy requirements, they could set up a community cloud for all of them to access. And then hybrid cloud combines multiple deployment models. For example, a company might have specific internal applications that they want to privately host, but then they also want to have services like web servers that they want publicly accessible. As organizations grow, one of the issues that starts to rise is the ability to scale with consistent results from performance, security, complexity, and many other areas. Infrastructure as code, or IAC, involves creating configuration files or scripts that automate the process and produce consistent results for easily scaling cloud infrastructure. There's two major concepts that you need to know related to infrastructure as code. The first concept is automation, which is important because managing a single server with a small number of people is usually fairly simple to maintain or manually configure. But if all of a sudden you have 10, 20, or 30 servers, that easy task just became a nightmare. Mistyped commands, missing system patches or updates, and troubleshooting are all issues that become increasingly more of an issue at scale. With IAC, automation is easy to create identical systems or deploy fully patched systems that don't have compatibility issues. Orchestration is the second concept, and that combines automated processes into bigger, multifaceted processes called pipelines or workflows. Basically, the goal is to streamline the development, testing, deployment, and maintenance of a workflow like deploying servers. Continuous integration, continuous deployment, CI/CD, is a very common type of orchestration that I recommend you research. This process takes new code, quickly runs through automated checks, and if everything passes, the code can be pushed into production, or if it fails, then it's sent back to a developer. All of this makes the process run extremely fast compared to older styles. Computers aren't the only thing that's being virtualized, so is networking. Just like VLAN-capable switches are using a software layer to create and modify VLANs, software in general is starting to perform classic network functions. Think about if you hosted 100 virtual machines on a single server. It's possible that some of those virtual machines need to be isolated on their own private network, or even just have direct internet access for whatever reason. Many hypervisors come with the ability to perform network capabilities like built-in switching. Some of the options include virtual switches or vSwitches, which allow you to assign virtual network interface cards or VNICs with their own MAC address. This ultimately turns your hardware network port into a trunk port or an uplink port. As you start to get several virtual switches, you can use a distributed switch to manage all of them, just like you have a centralized management for physical switches. Virtual routers and firewalls serve the same basic purpose as a physical piece of equipment, and they run on their own virtual machine. Network Function Virtualization, or NFV, is a network architecture that was created by big telecommunications companies in order to take advantage of practices that cloud operators were using to manage their networks around the year 2010. The biggest part of NFV architecture is the Network Function Virtualization Infrastructure, NFVI, which consists of hardware and software like hypervisors that form the virtual network. NFVI is where the network functions like routing, firewalls, and so on run, and these functions are called virtualized network functions, or VNFs. One or more VNFs can be connected together, also called VNF components, or VNFCs, that collectively work as a single VNF, such as routing. This idea gives internet service providers two major benefits. First benefit is they can consolidate often incompatible boxes from different vendors that are in their networks into a small number of servers that are compatible with everything in their data center. The second benefit is the internet service provider can adjust the available amount of system resources in real time to make things run better. The NFV orchestrator is the software that can help make these adjustments on the large amount of devices that exist. Let's talk about software-defined networking, or SDN, real quick so that you don't get it confused with NFV. Traditional networking gear has two different planes. It has a control plane that decides how to move traffic and where to configure the devices, and a data plane or forwarding plane that executes those decisions based on what the device knows. Software-defined networking, or SDN, removes that control layer of individual devices and instead relies on a network controller to determine how traffic is moved throughout a network on the data layer or infrastructure layer. Another key aspect of SDN is that it's programmable, so developers can write code to control how the network actually behaves. SDN also introduces a management or administration plane responsible for setting up network devices with the right controller, and the application plane is where the network behavior controlling software actually runs for things like monitoring and enforcing security policies. The big difference between SDN and NFV is that SDN virtualizes the control plane to give the network controller its duties, where NFV virtualizes the entire network function. Typically, NFV uses SDN to accomplish its objectives. It's pretty common to have cloud systems that need to interact with local on-premise resources. First option you can do is using a VPN, or a virtual private network. VPNs can provide a site-to-site connection inside of an encrypted tunnel between your local network and a virtual network in the cloud. The second option is to use a private direct connection. You can do this by either running fiber directly between you and your cloud provider, or you can lease a line from a third party. None of this traffic goes over the public internet, and it's directly between you and your cloud provider.